Alright, hey AP Chemistry, I wanted to make the quickest video of things that you need to include or you should read and understand, and things that you don't need to in your outline for Chapter 18. So I skipped over to Section 18.2. It's very important that you know what I mean or what we mean by spontaneous. Know the definition of spontaneous and non-spontaneous, and then making sure you have many examples. What's very important is knowing the difference between spontaneity and things that are happening fast. Speed is not the same thing as spontaneous. Something could be very slow, but still be spontaneous. In addition to that, you are going to need to know all of the different melting and boiling points for water, which is basically 0 and 100. You need to know this. The melting of ice above 0, evaporation of liquid water, and dissolution of sodium chloride. Know these three things, and if that's the thing that could happen, like solubility, like you put salt in water, that works. You need to know spontaneity and understanding entropy, which is next. In order to do that, a lot of the questions are going to be around you understanding water. So, for example, the melting point of water is 0 degrees Celsius. If anything is above 0, water is going to melt. If it's below 0, it'll freeze. So if I say something like water at 10 degrees Celsius, will it spontaneously freeze? You would say no, because above 0, it's going to melt. So it would spontaneously melt. So read and outline and understand that. You need to know the melting and boiling point of water and whether or not it will freeze or boil. That's going to help you with understanding a lot of the questions. And then moving on, understanding what entropy is, right? You do need to understand the definition of entropy, randomness. I would sketch kind of like these particle diagrams or get an idea of what they are asking about, and then make sure you know this definition of entropy. And a simplified definition is randomness and disorder. So if you think about entropy, things want to end up being random and disordered. So gases have the most entropy, you'll read that later, and solids have the least entropy. Solids are very organized and all together. Gases are all randomly and about, okay? You could skip this equation here. I will not ask you, and the AP exam does not ask you about microstates or this equation. Do not worry about this. Skip, this equation and understanding like the system A, B, and microstates. Do not do that. That's more like when you get to college or like advanced chemistry topics. You do need to know the second law of thermodynamics, which is for any spontaneous process, the entropy of the universe increases. So entropy increasing is a law of thermodynamics. The first law you learned in chapter 6, which is the sum of all the energy of the system is the total energy. So it's kind of like conservation of energy is the first law. This is the second law. You might want to write in your outline and remind yourself the first law of thermodynamics, because I will ask you about that. Again, the first law is delta E is equal to Q plus W, which basically is the conservation of energy. So all the energy of the system is equal to the total energy. Now, this whole thing about entropy change upon the expansion of an ideal gas, you do not have to outline that. You do not need to know about microstates. I'm not going to ask you about microstates, and the AP exam is not going to ask you about microstates. So you can ignore this section that says entropy change and all of 847. You will need to know this delta S equation, final minus initial. We're gonna do equations and calculations with this later in the chapter. So you will need to know that if I want the total change in entropy, it's final minus initial, okay? So you do wanna kind of record all of this information and read changing in entropy about that. Then the last section is 18.4, entropy changes associated with state changes. You do need to outline and understand this. So make sure you read and understand the entropy of a sample increases as it changes the state from solid to liquid to gas. Gases have the greatest change in entropy. If I'm going from like a solid to gas or a liquid to a gas, I'm increasing in entropy. The opposite, if I'm going from a gas to a liquid or a gas to a solid, I'm decreasing in entropy. Entropy is like all the particles are all over the place, so you need to think about that. So you will need to read and understand this concept. Entropy increasing. Gases have the greatest entropy. Solids have the least entropy. Make sure you know that. And then make sure you know how to predict the sign of entropy. do these examples. I would do these practice examples here, predicting the sign. So for example, going from H2O gas to H2O liquid, the particles going from a gas to a liquid are coming closer together. They're becoming more organized. That is decreasing in entropy. So this would be negative, and that's what it says. Delta S would be negative. N2O gas to 2N2 gas plus O2 gas. This is another way in which you'll read in this section. I have 2 gases on the left side and 3 gases on the right side. 2N2O is 2 gases. 2N2 and 1O2 are 3 gases. This is an increase in entropy. I'm getting more gases, and that's what it's going to say. Delta S is positive. So make sure you read and understand that in section 18.4, and you will have to predict whether entropy will be positive or negative in your Google form and on entrance tasks. Reading about that, and then do these little example questions. I'll probably throw those on your Google form. And then this last thing about calculating delta S, I would record this equation. You will and may need to do calculations involving delta S. So doing this example problem, and it goes on to 852, but I don't have it here, being able to calculate entropy if you have the heat and the temperature. And it's got to tell you that it's a reversible process. You could quickly or minimally outline this. I want your focus to be for your outline, understanding how to do something like this in example 18.1. Okay, so hopefully this was super helpful for you to get you to begin thinking about outlining Chapter 18. Let me know if you have any other questions, comments, concerns about outlining Chapter 18, Sections 8.2, 3, and 4.